Essay all about Neptune. 1. Introduction. Neptune, the distant blue giant of the solar system. Among all the planets in the solar system, Neptune is one of the most mysterious, remote, and beautiful. It is a world of deep blue color, supersonic wind, violent storm, freezing darkness, and extraordinary scientific mystery. At the eighth planet from the Sun, Neptune occupies the far outer edge of the major planetary family, where sunlight, the weak, temperatures are incredibly low, and the solar system begins to feel truly vast and alien. Neptune is often called the ice giant, a term used to distinguish with the largest gas giant Jupiter and Saturn. Although Neptune may appear calm and elegant from a distance, it is actually one of the most violent and dynamic planets in the solar system. Its atmosphere is home to some of the strongest winds ever measured on any planet, reaching astonishing speeds that can exceed the speeds around sound on Earth. Neptune is also a planet of paradoxes. Its light is extremely far from the Sun, yet it is still meteorologically active. It receives very little solar energy, that it produces giant storms and powerful atmospheric movement. It is dark, cool, and distant, but it remains one of the most captivating worlds ever discovered. The planet is named Neptune after the Roman god of the sea, with highly appreciated because of rich ocean blue appearance. However, Neptune is not covered in liquid water ocean like Earth. Instead, it is a giant world made of gas, icy rich material, and exotic fluids under intense pressure. One of the most fascinating things about Neptune is that it was the first planet discovered through mathematics before it was directly observed. Covered one of the greatest triumphs in the history of astronomy. In this essay, we will explore everything important about Neptune: its origin, structure, atmosphere, color, weather, rings, moon, discovery, scientific importance, and the many mysteries that still surround this distant world. What is Neptune? Neptune is the eighth farthest major planet from the Sun in the solar system. Order of planets from the Sun: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Neptune belongs to the group of outer planets that are classified as an ice giant. This category includes Uranus, Neptune. Neptune is different from the terrestrial planets like Earth and Mars because they do not have the solar rocky surface that humans could stand on. It is also different from the larger gas giant Jupiter and Saturn because it contains a larger proportion of heavier volatile materials such as water, ammonia, methane. Basic facts about Neptune. It is the eighth planet from the Sun. It is one of the two ice giants. It is famous for its deep blue color. It has extremely powerful wind. It has rings. It has many moons. It is one of the coldest and most distant worlds in the solar system. Neptune is a planet of combined beauty, violence, and mystery in a truly extraordinary way. The size and physical characteristics of Neptune. Neptune is a very large planet, though it is smaller than Jupiter and Saturn. Important physical facts about Neptune. Diameter about 49,244 km, radius about 24,622 km, mass about 1.024 times 10 squared to the power of 6 kilograms mass compared to Earth, about 70 times Earth's mass volume. Enough to hold about 57 Earths. Neptune is slightly smaller than Uranus diameter, but is more massive and denser. This means Neptune packs more matter into the slightly more compact volume. Even though it's far from Earth and difficult to observe, Neptune is still large and enough to world much closer. It will dominate our sky as one of the most impressive worlds visible. The origin formation of Neptune, like the other planets in solar system, Neptune's formed approximately 4.5 to 4.6 billion years ago from the giant cloud of gas and dust and surrounded the young sun. Neptune's life informed to the following process. Dust and ice particles collided and accumulated. These materials formed larger planetesimals. A growing planetary core attracted more surrounding material. Neptune developed into a giant world rich in volatile compounds and gases. Because Neptune formed far from the Sun, temperature in the region was low enough for substances such as water ice, methane ice, ammonia ice to exist to solar photons formed during planetary formation. That is one of the reasons Neptune is called the ice giant. Scientists are still investigating exactly where Neptune formed and whether it may have migrated from a different region during the early history of the solar system. This is important because Neptune's movement may have played a major role in shaping the outer solar system, the kind about the distribution of icy body in common. Neptune's position in the solar system. Neptune is located incredibly far from the Sun. Average distance from the Neptune to the Sun, about 4.5 billion kilometers, that is roughly 30 times farther from the Sun than Earth is. Because it's an enormous distance, sunlight at Neptune is very weak. If you stood near Neptune, the Sun would appear much smaller and dimmer than it does from Earth, still bright but no longer dominating the sky in the same way. Distance from Earth to Neptune is the distance between Earth and Neptune changes depending on orbital position, but is usually around 4.3 to 4.7 billion kilometers. That is enormous distance, makes Neptune one of the hardest planets to study in detail. Even radio signals traveling at the speed of light take hours to move between Earth and Neptune. The discovery of Neptune, a triumph for mathematics. The discovery of Neptune is one of the most remarkable stories in the history of astronomy. Unlike the planets visible to the naked eye, Neptune cannot easily be seen without a telescope. It was officially discovered in 1846. But what makes that discovery extraordinary is that scientists predict its existence before they actually saw it. How does that happen? Astronomers noticed that its orbit of Venus was behaving strangely. It did not move exactly the way expected based on no gravitational forces. This led scientists to suspect that another unseen planet might be pulling on Uranus gravitationally. Using mathematics, astronomers calculated where the hidden planet should be. Soon after, Neptune was observed almost exactly where predicted. This was a huge scientific victory because proved that mathematical reasoning to reveal unseen world. The discovery of Neptune showed that human intelligence could extend to beyond direct observation and uncover hidden architecture of the universe. Why is Neptune blue? One of Neptune's most striking features is the crisp blue color. Why did Neptune appear blue? Mainly because of methane and its atmosphere. Methane absorbs red light from the sun and reflects and scatters more blue wavelengths, giving Neptune its characteristic blue appearance. However, Neptune's color is often deeper and more vivid than usually. Scientists believe this may involve additional atmospheric process that's not yet fully understood. The deep blue color is one of the main reasons Neptune appears so visually beautiful and ocean-like, even though it's not a water-ocean planet. A day and a year on Neptune. Neptune has very different time cycle compared to Earth. A day on Neptune. Neptune takes about 16 hours to complete one rotation on its axis. That means the day on Neptune is shorter than a day on Earth. A year on Neptune. Neptune takes about 165 years to complete one orbit around the Sun. This means Neptune moves very slowly around the Sun because it is so far away. In fact, since its discovery in 1846, Neptune completed its first full orbit since discovery only in 2011. That means a human entity to wait 165 years just to witness one completely Neptunian year after its discovery. Does Neptune have a surface? Like Jupiter, Saturn, and Orion, Neptune does not have a solid surface that humans could stand on. If you try to dance to Neptune, you will not find a normal ground like Earth's crust. Instead, you will move through increasingly dense layer atmosphere and fluid-like material. Its spacecraft fell into Neptune. It would encounter thick clouds, increasing pressure, falling temperature in some layer, then rising temperature deeper inside, violent wind and turbulence, eventually crushing pressure and destructive heat. So while Neptune is often raw and this blue sphere, it is actually a violet layer giant with no simple surface in the normal sense. The internal structure of Neptune. Scientists believe Neptune has complex layer structure. Neptune likely contains 1. outer atmosphere, this is where visible cloud, storm, and wind exist. 2. Mantle a deep layer rich in hot dense fluids made from substances such as water, ammonia, methane. This is not ice in the everyday sense. Under Neptune extreme pressure and heat, these substances may exist in exotic fluids supercritical state. 3. Core, a central region likely made of rocks, metal, heavier material. Neptune exterior is one of the reasons it's so scientifically interesting. Deep inside, matter behavior of way very different from anything natural experience on Earth. Neptune's atmosphere is a powerful dynamic system. Main components of Neptune's atmosphere: hydrogen, helium, methane, trace amount of other compounds may also be present. The atmosphere is arranged in layers and contains cloud system, storm, atmosphere, as band, haze, fast-moving weather structure despite receiving so little energy from the sun. Neptune's atmosphere is incredibly active, which is one of the which mysteries scientists continue to study. The strongest wind is in the solar system. One of the most astonishing facts about Neptune is this. Neptune has some of the fastest wind ever measured in the solar system. Wind speeds on Neptune can reach more than 2,000 km per hour. That is faster than the speed of sound in Earth's atmosphere under many conditions. These are not just ordinary winds or storms. They are planet-scale atmospheric forces of incredible violence. Why are Neptune's winds so strong? Scientists are still investigating this question, but possible reasons include internal heat escaping from the planet's atmospheric pressure differences, rotational effects, complex fluid dynamics. This makes Neptune one of the most meteorologically extreme worlds known to science. Giant storm on Neptune. Neptune is famous its first giant storm, formed which resemble grids on Jupiter and concepts though behave differently. One of the most famous observed features was the Great Dark Spot. These were the large storm system discovered by the Voyager 2 spacecraft when it flew past Neptune in 1989. What was interesting about the Great Dark Spot is was a giant atmospheric storm. It resembled massive cyclone-like a system. Its layers disappeared. It shows scientists that Neptune weather is not only violent, but also changeable and dynamic over time. Other dark spots and storm systems had been observed since then, proving Neptune's atmosphere is alive with motional instability. Neptune's clouds are made of different materials depending on altitude and temperature conditions. Some of the upper visible clouds may contain methane ice crystals. These clouds can appear in bright streaks or patches in Neptune's atmosphere. Neptune's clouds are important because they help scientists study wind patterns, atmosphere in motion, storm development, physical structure of the atmosphere, even though Neptune is extremely distant. Modern telescopes and spacecraft observation have allowed scientists to detect moving clouding systems and changing weather. That means Neptune is not a static frozen world, it's a living atmospheric machine. Temperature of Neptune. Neptune is one of the coldest planets in the solar system. Average upper atmospheric temperature about -240 degrees Celsius. Extreme cold is due largely to its great distance from the Sun. However, Neptune is still eternally active. One of the fascinating facts about the planet is that it radiates more energy than is received from the Sun. This means Neptunes have an internal heat source or retained heat that continue to affect its atmosphere and structure. That internal energy may be one of the reasons why Neptune weather is so much more active than many people would expect for such a cold and distant planet. Neptune's magnetic field. Neptune has a magnetic field, but is unusual. Unlike Earth's relatively centered, more symmetrical magnetic field, Neptune's magnetic field is tilted of offsets from the planet's center. Some regular this success of the field may be generated in unusual regions of the planet's interior rather than in the simple central core like Earth. Studying Neptune's magnetic field helps scientists understand how magnetism can work in giant planets with strange internal structure. This is also important for understanding explore planets that maybe resemble Neptune in another star system. Does Neptune have rings? Yes, Neptune does have rings. This surprises many people because Saturn is the planet most famously associated with rings, but Neptune also possesses a ring system. Neptune's rings are paints that difficult to observe, made of dust and small particles. They are not nearly as spectacular or reflective as Saturn rings, but they are still scientifically important. One especially interesting feature is part of Neptune rings appear to contain denser clumps to Earth, which has long eclipsed astronomers. This ring may be shaped and maintained by gravitational interaction with Neptune's moon. Neptune's moon system. Neptune has many moons, each with their own unique story. Some small and irregular, but one moon stands far above all the other in importance. Triton is Neptune's largest moon and one of the most fascinating moons in the solar system. Triton. Neptune's extraordinary moon, Triton is one of the strangest moons known as Triton. Why is Triton so special? It's Neptune's largest moon. It orbits Neptune's backward retrograde orbit. It's extremely cool. It may be geologically active. It's likely it did not form around Neptune. Originally, scientists believe Triton may actually be a captured object from the Kuiper Belt, a distant region of icy body beyond Neptune. If this is true, then Triton is, and not just the moon, it is captured world. Triton's frozen surface and active Voyager when Voyager 2 flew past Neptune. It revealed that Triton has a Triton's icy surface and even cyan activity. Voyager 2 discovered that Triton has nitrogen ices, frozen crust, unusual terrain, dark streaks on the surface, possible cryokinetic activity. One of the most amazing discoveries was evident Earth. Gas of life are options. They may involve nitrogen gas and dust material reacting from beneath the surface. That means Triton is not the frozen dead moon. It may still be an active world. Even extreme cold the outer solar system. Could Neptune or its moon support life? If we are talking about Neptune itself, the answer is almost certainly no. Neptune is far too extremely for life as we understand because of no solid surface, extremely cold, crushing pressure, violent atmosphere. However, some scientists remain interested in whether moons like Triton might hold scientific clues relevant to habitability or subsurface chemistry. Triton is not currently considered one of the strongest life candidates in the solar system compared to places like Mars, Europe, and Chaldeus. Triton, but is still scientifically important and may preserve secrets about icy world in the outer solar system. Voyager to humanity only close visits to Neptune so far. Only one spacecraft has visited Neptune's close. Voyager 2 in 1989. Voyager 2 performed a flyby of Neptune and transformed our understanding of the planet forever. Voyager 2 revealed Neptune is storm system, the great star-spot fast-moving cloud in its ring system. Detail about planets and important magnetic field data without Voyager 2. Neptune would be still be little more than a distant blue dot. Its flyby remained one of the greatest achievements in space exploration and one of the most important moments in our planet's science. Why Neptune matters to science? Neptune important not just because it's beautiful and distant, but because it's how scientists answer major questions about planetary formation, atmospheric physics, ice, ion structure, magnetic field, outer solar system evolution. Exoplanets is especially important because many planets discovered around other stars seem to be similar in size or type to Neptune. That means studying Neptune helps scientists better understand not just our solar system, but planetary system throughout the galaxy. Neptune and its exoplanets are an important scientific role is today and a comparison model for planets far beyond our solar system. Many exoplanets discovered so far are to be Neptune-sized, mini Neptune, ice ion last word. By studying Neptune, scientists gain insight into how atmosphere behave under different conditions, how giant planets evolve, how planetary migration may work, how come in certain type of planets, maybe in the universe in this sense. Neptune is not just a distant member of our solar system. It is the key to understanding world across the cosmos. The future of Neptune exploration. Neptune remains one of the least explored major planets in the solar system. Scientists would love to send future missions to study. Neptune's atmosphere, its internal structure, its magnetic field enriched Triton, possible cryovolcanic activity, long-term weather pattern, the dedicated Neptune Orbital or Triton mission could completely transform our understanding the outer solar system. Because Neptune is so far away, that missions are difficult and expensive, but scientifically they could be incredibly valuable. Conclusion: Neptune is one of the most beautiful, powerful, and mysterious planets in the solar system. It is worth of deep blue color, crushing wind, giant storms, strange magnetism, faint ring, and extraordinary distance. It lies at the edge of the Sun planetary family, where cold, darkness, and time seem to stretch into something almost unimaginable. Yes, Neptune is not silent or lightless in the scientific sense. It is active, dynamic, and full of unanswered questions. From its mathematic discovery to the astonishing flyby of Voyager 2, Neptune has continually reminded humanity that even the most distant world can hold dramatic beauty and profound scientific importance. The more we study Neptune, the more we realize that the solar system is not empty or simple. As it rich its hidden complexity, alien weather, frozen moon, and comet story still waiting to be understood. Neptune teaches that distance to not reduce wonder. If anything, it deepens it.